Quiz on equations. Problem number 1. We have to solve this given equation. To solve this equation, isolate for x, of course. So let's get rid of this negative 8 that is bothering the x. So I'm gonna do plus 8 here, plus 8 here. Let's see what we're going to get from that. So my equal sign remains there. This is gone, and I have an x. Negative 52 plus 8 is going to give you a negative 44. So that should be your final answer. And we box our answer. Now let's just do here problem number 2. I'm going to break the board in half. So problem number 2. What I'm going to get here in problem number 2, well, it's given that x over negative 3 equals to 7. Well, I need to get rid of this negative 3 here that is dividing the x, right? Because you want to leave the x by itself. Therefore, what you need to do is you got to multiply it by negative 3 each side. So I'm going to multiply this pi by negative 3 and multiply this side by a negative 3. Look what's going to happen right now. What's going to happen is that this negative 3 and this negative 3 is going to be gone. That was the purpose of multiplying by negative 3. So x is by itself as desired. So 7 times negative 3 is going to be negative 21. So that should be your answer. Let's keep going and do problem number 3. In problem number 3, we have fractions involved in this equation. So whenever you have fractions involved in an equation, you try to get rid of these fractions. We're going to clear these fractions. How are we going to do that? You must find the least common denominator between 4, 2, and 5. So after you have done that, you will find out that the least common denominator between 4, 2, and 5 is 20. So if you need to review your LCD, make sure you check the video in chapter 5 in Math E for you to be able to review the LCD. It's crucial. By now you're supposed to get it. We're doing the quizzes. So LCD equals to 20. Now I'm going to rewrite, just because I don't want to be squeezing my numbers here. I'm going to rewrite everything by times 20. So I'm going to put a 20, and it's preferred if you do 20 over 1. 20 over 1 times 3x over 4 plus, now here comes a 20 over 1 times 1/2 equal, I prefer my equals to be aligned. It didn't happen. But try to align them. So times 4/5. Okay, so it's better for you to write it like this instead of squishing it here. So now it's time for us to cancel. So here, if I'm gonna cancel, 4 goes into here once, 4 goes into here 5 times. Now I'm left with a 5 and a 3x, which is gonna be 15x. No more fractions. That's what we wanted. So same technique here to the next following term here. 2 goes into here once, 2 goes into here 10 times. 10 times 1 is positive 10. No more fractions. That's what we wanted. Same idea here. 5 goes into here once, 5 goes into here 4 times. 4 times 4 is going to be 16. Now we have to leave the variable by itself, so I'm going to have to subtract 10. I got to get rid of this. Minus 10 here. So that will give us 15x by itself. 15x equal to 16 minus 10. That's going to give us 6. Now I'm going to have to divide each of them by 15. Divide this by 15. And then you will get, well, 15 and 15 is going to be gone. Here they do have something in common. They actually have a 3 in common. 3 goes into here twice. 3 goes into here 5 times. Therefore, my final answer, therefore, these 3 dots means that, therefore, x is equals to 2/5. Problem number 4. Another equation here. There is no fractions, there is no parentheses. Therefore, let's just combine like terms. Can we combine like terms in each side of the equation? Seems like we can't. So now it's time for you to leave the variables in one side and the numbers to the other side. So I'm going to procedure and do this minus 5x here. Minus 5x. And we will get 3x minus 5x is going to be negative 2x, negative 2x. We keep our negative 7 equal to positive 3 because now these are gone, so it's just going to be positive 3. Now I got to get rid of this negative 7 because our goal is to leave this x by itself. Therefore, to get rid of this negative 7, I'm going to have to add 7 each side, plus 7, and these one are going to be gone, disappear now. So you have a negative 2x equal to 10. Right, now we're gonna have to divide by negative 2 because you want the x to be by itself. You just do not divide it by 2. You also have to include this negative number here. So you can have negative 2 divided by negative 2. It will be completely gone. So it's just gonna leave you with a single x here. Now 10 divided by negative 2 is going to be negative 5 because a positive and a negative, whenever you're dividing numbers that they have different signs, it's going to be a negative outcome. So x equals to negative 5. Problem number 5, we do have some parentheses here. So let's clear those parentheses now. Whenever we're doing this, I'm going to have to multiply, get all of these 4 here and multiply. And then we multiply times the negative 5. So you have 4x minus 20, because 4 times negative 5 give you negative 20, equal, same technique here, 2 times 2x is going to be 4x. 2 times negative 7 is going to be negative 14 minus 6. Now, once the parentheses are clear, combine like terms is if possible. It's not possible on the left side, so I'm just gonna copy the 4x minus 20. Let's see if it's possible on the right side. Now, yes, I have these two numbers here that I can combine. The 4x, you couldn't do anything there, so just put the 4x. Negative 14 minus 6. What is negative 14 minus 6? That's actually negative 20. Now, move the variables to one side because you want to leave the x to the left side, right? So minus 4x here. And look what's happening here. This is gone and this is gone. Negative 20 equals to negative 20. And recall, when the variables are canceled out in the procedure, you check if this one is true or false. Negative 20 equals to negative 20. That's actually true. So we have an identity equation, which means that we have infinite many solutions. So actually your answer is all real numbers. All real numbers. So you can give that as your answer. X belongs to the set of all the real numbers. Or you can just write R. Okay. So actually whenever you're doing this, you have a 4x minus 4x and 4x minus 4x. The variables are gone. You just check if this is true or false. If it's true, in this case, it's all real numbers as an answer. If it would have been false, then you say no solution.